to write an assembly language code for MIPS types of processor, right? Whenever we write the code in chapter number 4, that is for Intel processor, which is the CISC types of processor. Here, this is VIX types of processor, and the processor name is MIPS R2000, right? And that's why, because the R2000 is 32-bit processor, and all the registers are 32-bit long. That's why all of our codes or instructions, if you convert them into the binary, then it will be also 32 bits long. That's why it starts from 0 to 31. Okay, so we have 3 types. In our course, we have used the I type, which is the immediate type, and the R type, which is the register type. The jump type, which is the J type, we have not used in this course because it is quite complex, or we don't have actually time to do that. Fine, so we usually use the I type or the R type. So what does that mean? So we need to follow some formats to write a code. If you want to write an I type or if you want to write an R type. So if you want to write the immediate type, then we have to write the opcode, 2 register, and 1 immediate value. For example, this one. This is the example. If you compare this one with the formats, right? So this is the opcode, add I. Why it is add I? Because we know that we have several types of add. Just add, or add U, or add I. Add I means we have 1 immediate value. That's why we have to use add I. So if you match with the format, so this is the opcode. This one. This is register number 1, which is we call source register. This is register number 2, which we call the destination register, and that we call the immediate value, which is this one. So if you convert them into the binary number, then the value, the binary number, it will be 32 bits long. So that's how we can write code in I type. Remember one thing, that we actually, as a programmer, we really don't want to know or don't need to know most of the time that what are the binary equivalent and what are the things, but we need to keep in mind that whatever we are writing, it's actually converting into this way. That's why we need to know this. Whenever we write the code, that time we actually don't need to know that. Don't need to consider that if we just follow the formats. Same as the third one, as we have not described the second one. Third one is if you think about the R type, and if you think about the formats, first one is the opcode. This is the opcode. One source, another source, and another source. That means we have 3 registers here. As we have 3 registers here in different names, for one source register, destination register. So we have 3 registers. These are the 3 registers. So you are thinking that where are these 2? As I said, that generally we don't need to consider some of the other parts, especially these 2 parts. Most of the time, this part and this part is 0. This is 0 always, most of the time, and this one depends on which type of opcode you are using. Okay, these 2. So generally, we don't need to write this one. So whenever we write code, if you just write this as a programmer, that will be fine. Rest of the task will be done by the assembler and the processor. Okay, if you want to see the equivalent code of this high-level language, then it will be this. So this one we'll consider as A, this one we'll consider as B, and this one we'll consider as C. Because we know that whenever you write add, these 2 numbers will be added together and the result will be stored into this register always, especially for the MIPS. All right, so that's how we write the code in R type. That means the register type, where we have 3 registers, whereas in I type we have 2 registers and 1 immediate value. That is the only difference. Whenever you write the code, that is the only difference. Let me tell you again, look at the difference. This code add add and then 3 registers, and here add I 2 registers and a number. That is the only difference. Whenever you write the code, I type and R type. Fine. So you can read it from here. You can also read it from here, or also you can just Google it. So that is our instruction format. So we have discussed. Now we have discussed, after that we have discussed about the transferring the data. We have 5 different types of instructions. LB, that means load byte. LBU, load byte unsigned. LH, that means load half word. LHU, load half word unsigned. And LW, that means load word. Depending on the size of the address or depending on the size of the value, you choose either one of them. Okay, very simple. Remember one thing, we are not going to discuss or consider this assembler serial instruction. So don't worry about that. After that, we have discussed 4 basic arithmetic instructions. First one is the addition, very simple. We have already seen that add and then 3 register name. So source 1 and source 2 will be added to each other, and then the result will be stored into the destination for the first register. Simple as that. In add, we might have an overflow, and in that case, there will be exception is generated if it is there is an overflow. But if you use add u instead of add, if you use add u, then there will be no exceptions. Second thing, third thing is you can use add I whenever you use an immediate value like this, add I. Fine, so that is the addition. Subtraction also the same. Sub, and then 3 register. We know that this register minus this register, and then the result will be stored it here. As you can see, it is written here. If you just read the book, it is quite simple. They have explained very nicely. So that is the subtraction. We have also discussed about the multiplication. So MULT, and then 2 register. So the value of the 2 register will be multiplied to each other. And now the question is where you are going to store the results. Where you are going to store the results?
Into special purpose register.
Into two special purpose register. Yes, correct. Into 2 special purpose registers. So how we can store it?
For lower 16, lower 32, lower 16 bit will be stored in LO and.
No. What is the size of the one?
Sorry, lower 32 bits.
What is correct? What is the size of each of the register?
32 bit.
32 bits. So when you multiply, how long it will be the size?
64.
64 bit, correct. So we don't have any 64 bit register. That's why we use 2 special purpose register, LO and HI. So lower 32 bit, that means rightmost 32 bits will be stored into the LO register, and higher 32 bits, that means leftmost 32 bits will be stored into the HI register. So you might think that if we want to multiply, what will happen if you want to multiply, let's say 1 bit by 2 bits? Can you do that?
We have to convert it into 30 bit.
We have to convert it into the 32 bit first. There 1 bit and 2 bits number, and then we multiply. Simple as that. Very similar to this. Look, the value is only 4, but our space is 16 bits. Obviously, rest of the bits will be all 0 because these are unsigned values. Fine, so that's how we also do the same, the other one, multiplication. Fine, so if you understand the multiplication, you should also understand the division as well. So div, source 1, source 2, and we know that source 1 divided by source 2. Now the question is, how many results do we have after division? 2. And those are
Question and remainder.
Question and remainder, right? Correct. So we also don't have other registers to store this value. That's why what we did, we stored those two results into two registers. So the question value will be stored into the LO register, and the remainder will be stored into the HI register. That's how we do the division. And there will be no overflow happening. Okay. And we also discussed about the logical instruction. So we know that the logical instructions are quite common. Just one extra thing, which is if there is one value is immediate value, then we use and I. All the same, just and I. Or I. It's or I is an immediate value. So the last one will be the immediate value. So you can see that IMM16. IMM16 means immediate value, which is 16-bit long. Fine. So that was the last topic of this chapter number 13. Anything else that you want me to discuss? That is chapter number 13. Let me just remind you that what are the topics we have discussed so far from the very beginning. Let me just show you from the book. You can check it from the the slides as well, and from the video. By the way, I don't have any video for chapter number 13. So nothing. So in chapter number 1, we have started with the high level and low level language, system dependent and system independent, system dependent and system independent language, high level and low level language that we have discussed. The overview of our computer system. I think you remember that I told you that this image you will see at least 4 to 5 times in your entire graduation in different courses. So make sure you understand this one very nicely and clearly. We have discussed about the 2 different types of processor, CISC and RISC. We have some example of CISC. We have example some RISC. This is the RISC example. We have discussed, I think, for chapter number 1, I think we better discuss it in the introduction. So CISC and RISC processor. Advantage, disadvantage, features, examples of CISC and RISC processor, then the difference between CISC and RISC processor, then of course about the assembly language, 2 different examples of the assembly language, advantage of high level language, advantage of assembly language, and also by knowing the assembly language, what will be our benefits? These are the benefits. Disadvantage of assembly language, I think you remember that the disadvantage of assembly language is actually the advantage of the high level language, because we have 3 disadvantages in assembly language, and at the same way, these 3 disadvantages actually the advantage of the high level language, right? So very similar. If you know one, you can answer the other one. So the application of the assembly language we also have discussed, right? Like how where we can use it. 2 types of time critical. Time efficiency, time critical, and time convenience. Hopefully you remember this one, time convenience and time critical. Time convenience is it is better that you do it within the time limit, the task. If you cannot do it, it's fine, but it should not be harmful. But in the time critical application, you must finish your job within the time. Otherwise, some disaster can happen or some harmful thing can happen. These are the time efficiency, time convenience, and time critical. Some examples. Then that's it. So that is chapter number 1. You can read it from here. You also can read it from the book as well. Remember one thing I was talking about yesterday, these two examples. Here you can see that whenever you write any code, different length of machine language for 6 types of code, that is Pentium processor. If you look at the MIPS processor, these are all fixed length. Whatever you write, the length of the machine language, they are same. That is the advantage. That is the 5th feature. If you remember, 5th design principles, number 5. This is number 5, that fixed length of machine language. Okay, done. So let us see chapter number 2. So that is chapter number 1. In chapter number 2, we have discussed about the basic organization of the computers, which also is a very common topic. At least 3 to 4 courses, because you are going to see or learn, or you have already done in computer architecture and design, operating systems, and in this assembly language, microprocessor. So many other courses you actually do this. Learn the same thing. So hopefully it's much more easier for you. So this is the basic component of the computer architecture and organization. We have learned one interesting thing, which is that anything can be done by the software. That can be also done by the hardware, and anything can be done by the hardware also can be done by the software. These are the 3 basic components we have in our computer, including the system bus. It is 4, but generally we say that we have 3 components like input, output, main memory, and our CPU, and these are connected with system bus. All together we have 4 basic components, same as the processor as well. Again, you will see this kind of thing several times. So we have done after that one by one processor, main memory, input, output that we have discussed, and then one of the best thing we have done here is the system bus, which is quite important and it's quite common, and this also it is needed for so many other courses as well, which is the system bus. All right, so we have 3 different types of, or 3 components of a system bus. So all together they call it system bus. So we have address bus, data bus, and control bus. Address bus contains the address, data bus contains the data, and also the control bus is contains a special control signal like read, write, interact, this kind of thing. So we use it in the control bus. Fine. So our system bus, all these, they are connected to each other, of course, and they generally communicate with 3 other components: processor, memory, and input-output system. Then we have discussed about the processor. The first thing we have discussed about the processor is the cycle, the execution cycle, or the other name we call fetch, decode, execute cycle. So we have 3 cycles. We have 3 components in this cycle. We have to fetch the code first from the memory. Then we need to transfer or translate or decode the code to understand it, and then we execute. Right? Then we execute the instruction. That is called cycle, execution cycle. So that is the execution cycle: fetch, decode, execute. Fetch, decode, execute. After that, we have discussed about the system clock. That means each of the processor has its own system clock, and the unit is hertz. Based on that, we can say that how fast it is. For example, mine was 3.something gigahertz, let's say 3.2 gigahertz. That is, the processor can do 3.2 into 10 to the power 9 tasks in one second. All right? It's because it is per second. Fine, so that is our system clock. Number of addresses, we have discussed several types of number of addresses. 3-address machine, where we have 3 variables, very common into the MIPS types of processor we have done. So we have three address machine. We have discussed also that how we can convert any high-level equation into our low-level three address machine, and also for the two address machine, and also for the load and store architecture. We have practiced these three. I suggest you, please you also, practice. Okay, practice these three because it's quite common question. We also have discussed about one address machine and zero address machine. Generally, we don't use it. They use it for a very special reason, a very special scenario. I'm just giving you the idea, just to remind you what we have discussed so far, right? So that you can, at least, remind yourself that you have to study all these materials. Okay, after that, we have discussed about flow of control. So we have two types of flow of control: branching, where we actually jump, conditional and unconditional, and another one is the procedure call. So procedure calls, that is, you are doing something, and then in the process, suddenly you go to the other process, finish that task, and come back again. So that is the procedure call. By this procedure call and branching, the processor actually control the flow of tasks, because we have just one processor, but there are thousands of processes running at the same time. So the processor needs to control it. These are the two ways we can control. Then we have discussed about the memory. We discussed about two types of memory. Oh, before that, we have discussed two basic operations of the memory. One is the reading cycle. This one, another one is the writing cycle. Very, very simple one. And then we have discussed two different types of RAM, dynamic RAM or DRAM, which is our main memory, which is the DRAM. Another one is static RAM, which is our cache memory. Okay, we have discussed about the difference between these two as well. And at the, okay. One more thing, we have discussed several types of ROM, and in here, we have discussed 4 types, but in the book, there are so many other types. But if you know these 4 types, I think it's enough. But there are so many other types of ROM as well, not necessary. If you just know these types, 4 types is fine. Programmable, and there are 3 types of erasable. So hopefully it will be all right. After that, we have discussed about the input output. That is the end of chapter number 2. And the book, you also can read it from here, because most of the part I copy paste from the book, most of the thing. So whenever you read, it is better you read it from the book. Everything is from here. 0 address machine, 1 address machine, load store architecture, flow of control, branching. This is the branching jump. And then flow of control, procedure call. That is the procedure call. That is, you go to the other part and then come back again. And then the memory, I think we the basic memory operation, we can see. I just copy paste from here. The steps for the read cycle, for the write cycle. And then the types of the memory, read-only memory or the ROM. There are so many types of ROM they have discussed, so don't worry about that, okay? And input output. That's it. That is chapter number 2. This is chapter, after that we have discussed chapter number 3, which is the very, in my point of view, very interesting chapter. That is just history, because most of the time, generally, as an engineer, we don't read actually history. That what was this, what was that previously. But in this chapter, they actually give us a very brief idea about the previous content or so, which is quite nice. We actually must need to know that. If you know that how the previous processor is actually developing themselves and then now come to this situation or this model, then it will be easier for us to handle it. It's easier for us to code for these types of processor. Most of the time, whenever someone teach the assembly language, they start from 8086 or so, because it's quite simple and quite basic. Okay, so in this chapter, we have discussed about the history of the Pentium processor family. So it starts from 8080, then 8086, 8088, 186, 286, 386, then Pentium, Pentium 1, Pentium 2, Pentium Pro, and all those kinds of processors. So these we have discussed several times, so many times. Make sure you know this one properly with explanation. Then we have discussed about the registers, because if you want to write the code, you must need to know the registers. All right, so in Pentium processor, we have three different types of registers. General purpose register. General purpose register also divided into data, pointer, and index register, as it is written here. The general purpose register are further divided into the data, pointer, and the index register. But we also have other types like the control register and the segment register. Let's see one by one. We know that we have four 32 bits data register, which is one type of general purpose register. So all names are AL, AX, B, or BH, and the full name is AX, BX, CX, DX, and extended version is BAX, BX, CX, and DX. These are the data register. We have two pointer register, stack pointer, SP, and the base pointer BP. And we have another one is for the array. This is for the stack. This is for the array or the string operation. SI, source index, and destination index. Two types of. Then we have control register. We have two types of control register. One is the flag, 32 bits. Another one is the instruction pointer, IP, or EIP, extended instruction pointer. And we know that we have three different types of flag, 6 types of status flag, 1 control flag, and 10 system flag. We know many of them already. We already know many of them. Make sure you know the name as well, at least some of them. All right. I know what you are feeling. You are feeling like, my God, so many things. And my God, I have forgotten everything, right? That's what you're thinking, right? Most of you. I know. Remember, you have only 2 days left, and this is the last class. You have only 2 days left, 16 and 17. Right, and your exam is on 18th. By the way, our exam will be on Zoom platform. I will give a separate link for your exam, written exam. Okay, I will post it in the Google Classroom. So please check the Google Classroom regularly. I will post it maybe on Saturday, obviously maybe on Saturday, just before the exam, or maybe on Friday night. If I'm not, I have not forgotten. By the way, what do you think that, at least can you remember that we have discussed all this a little bit?
So I think,
Yes, sir.
yes, sir. So,
All right, okay. It will take a little bit time. If you just revise a little bit, it will take a little bit time, and then I think it will be all right. Whenever you revise, generally when I was a student, just before the exam, it was actually difficult to revise everything. What we did not revise once. Actually, I started from the beginning, chapter by chapter, topic by topic, and then finished at least more than once. Because I'm not that much, genius or meritorious student that, okay, I read once and then I can understand everything. I actually do several times. I need to do several times. then I can actually remember, or then I can answer it. Otherwise, for me, it is difficult. Same as during the classes as well. Whenever I have a new course or whenever I have a new semester, start a new semester, at least 1 or 2 weeks ago, I need to take preparation. Do you think that I can remember everything all the time? No. I need to revise sometimes. I need to just check. Okay, that is this, that is that. Okay. And also at the beginning of the semester, we need to study as well. I need to study as well. So that whenever I discuss, because if I have a confusion on any topic, how can I explain it to you? That's why I prepare myself just before at least 1 or 2 weeks before, whenever we have started our course. And then at least, for example, I have 6, 7 chapters. At least I study 2 or 3 chapters before the start of the semester. And during the semester, I start continuing my study. So it is actually common. It is really, really common. I think I told you several times that the best player in the world, they also need to do practice. Everyone, all the players, doesn't matter he is genius, doesn't matter he is a God gifted, merit does not matter. They all have merits. But still, they need to work very hard every single day. They need to train themselves every single day before the match, although they are the best player in the world. So think about it. We are not best student in the whole world, but still, we need to study. We need to study, we need to prepare ourselves as much as we can. So studying every time or regularly is actually a common thing. It is common for the faculty. Faculty always study before the class, prepare themselves. Of course, you also should do the same. Don't think that you are the only person in the whole world that study. We also study. I also study. Okay, so please prepare yourself. And it is quite common. Okay, so please prepare yourself well before the match. Before the match, I mean before the exam. Okay, and it is quite common. Anyway, so please study, all right? Otherwise, it is difficult. I know that many of the topics, they are very first time for you. You have heard it for the very first time, which is fine, no problem. But whenever I ask you during the Viva, whenever I ask you in the exams, if you don't prepare yourself well, it will be much, much difficult to answer it. And as you know that if you don't answer me properly, there's no way you can get marks. Doesn't matter this is your last semester. Doesn't matter if you actually have any other problem or something else. I ask you a question, you answer me, you get the marks. Simple as that. Okay. Please do not give me any kind of excuses during the exam or after the exam or before the exam as well. Like this is my last semester, I have some financial problem. If I don't pass, that will happen, this will happen. Because I heard every semester. Don't say that. If it is your last semester, if you have to pass this course, you have to think from the very beginning of the semester. You have to prepare yourself well from the very beginning of the semester. You are not supposed to tell me that this is your last semester or not, or you have any other problem or not. Please do not expect that you write wrong answer. You write wrong answer, or you did not write the answer. And just because you have some problem and I give you marks. Please do not expect that. Do not expect that it is your last semester and you didn't give me any answer and I give you marks because this is your last semester. It cannot be happening. It will never happen. So please do not give me any kind of excuses. Study, answer me properly. I will try my best to make the question as simple as possible because we have other sections as well, other faculties as well. So combinedly, we will have one question, which will be better for you. We will try our best. At the same time, we need to maintain the standard, because you know that whenever the accreditation body will come, whenever the UGC will come, they will check. First, they will check the question and also your answer script. Remember that. If there is any dissimilarities, or if there is any lack of it, required standard, then obviously we will have some problem. Right. So at the same time, you have to do both. You need to think about you as well, and you have to think about the standard, minimum standard as well. All right. And obviously, I can guarantee you that there will be no question outside the syllabus. There will be no question that which I have not discussed several times in the class. And there will be no question that you have not solved it by yourself several times, either in the exam or in the practice or in the quiz or by yourself. Okay, so you can understand that this type of question can come. So if you prepare yourself well, it is really not difficult to get marks from me if you study properly. All right, that is guaranteed. Anyway, so we almost finished because it is our last class. So after that, we have discussed about the 6-segment registers. 6-segment registers we have discussed. We have discussed 2 types of memory architecture: protected mode memory architecture and real mode memory architecture. Make sure you do it very well, because it's also a very common question as well. Real mode memory architecture. So I think that's all from this chapter. After that, we have discussed the longest chapter, which is chapter number 4, where we do our coding here for the Pentium processor. Fine. So we have discussed about the assembly language statement, different types of data allocation, defined directives, 5 types of defined directives. We have discussed about the range, some examples, multiple definition, how we do the multiple definition in several ways. We have discussed about the array, how we can define an array, like using the times, very important one. We have discussed and practice and answer it several times, this symbol table. Make sure you know it very well as well. Then we have discussed about the addressing mode. We have discussed 4 different types of addressing mode. 4 different types of addressing mode. We have done also the math as well. I mean, not math, code specific to the indirect addressing mode. Then some very basic about the data transfer, like move operation. We have 5 different types of move. Ambiguous, non-ambiguous, exchange. Some increasing, decreasing, some addition, subtraction. That's it. And that is it. But also please remember that we have this one. At least you know the name. Conditional and unconditional jump operation. At least the name. After that, we have discussed about chapter number 5. In the 5, we have discussed about the stack operation. Very short and easy chapter. The stack operation. We have discussed what is stack, how the Pentium processor implementing stack, addition and deletion. There are some rules to do that. The explanation of stack. We know that we have done. We have just 2 basic operational instruction, push and pop. We have done it several times in so many ways and so many classes. So hopefully you can remember all this push and pop operation. There are 3 uses of stack: temporary storage, transfer control, and the parameter passing. That will be the last part of the stack operation. After that, we have discussed about 7.2. In 7.2, we have discussed about multiplication and division. We have done the multiplication. There are 2 issues to do the multiplication. We have discussed how we can identify the signed and unsigned number, the code of the unsigned number, which is MUL, 3 different formats to do the multiplication, the code for the signed multiplication, which is I multiplication, IMUL, and we have also 3 different examples of signed multiplication by using the flag, status flag and overflow flag. Then we have done the division. We have done only one division with these two issues. And there are also 3 formats to do the division. And we have discussed and practiced several times of this division. Hopefully it will be all right for you. So that after that, I think we have discussed chapter number 12 and 13. So that's all of our entire syllabus. Any question before we leave final? Remember, this is our last time of this course. Do you have any question?
Sir,
Yes.
I have some confusion in division, sir.
What confusion?
Sir, here. In, sir, yes, sir, 7.4, example now. Sir, here we use, sir, XOR. Sir, in which math we use this line, sir?
Look at the number.
Which code?
Look at the number 5147, right?
Yes, sir.
And this is the equivalent hexadecimal number. How many bits do we have here?
Sir, 16 bit.
16. How many? Okay, so that means it's okay. Anyway, this is a 16-bit division. Look at the 16-bit division. No. Yeah, this is the 16-bit division. So the dividend, the value is 16-bit, right? But we have 2 separate
Yes.
registers. So the AX register is quite enough to store the 16-bit number, right?
Yes, sir.
Then what we are going to do with DX? What we are going to store into DX?
Sir, 0.
0, correct. So if we want to make the DX 0, how we can do that? We can do XOR with itself. For example, in the DX, there are some garbage value or, for example, no value. So if you just XOR to each other, then it will be all 0.
Okay, sir. I understand.
Sir, I have a question, sir.
Yes.
Sir, on same lines, there have sir AX equal to 5147D. What is the meaning of this, sir?
D
Yes,
means decimal. D means decimal. Look at this number, 5147. This is a decimal number, right?
Okay, sir.
D means
Sir,
decimal number. 5147 decimal number.
I understand, sir. Okay, then, sir, how we can assume that is 16-bit division or 8-bit division? It will be স্যার এটা কি প্রশ্নে বলা থাকবে? Sorry, sir.
Okay, let me explain. Look at the 8-bit division. In the 8-bit division, look at the source. What is the size of the source? 8-bit, right?
Yes, sir.
What is the size of the source in the 16-bit division? 16-bit.
Yes,
So
sir.
look at the question. What is the divisor? 300, right?
Yes, sir.
300 is the divisor. How many bits do you need to write or to store this 300?
So it's 8-bit, sir.
Is it possible to store 300, value of 300 into 8-bit register?
So
No,
it's
sir.
no, sir.
No, it's not possible because you can store maximum 255.
255, yes, sir.
Yes, sir.
Yes, but the value is 300. So it is not possible to store it here, right? That means
Yes,
we
sir.
need bigger space. So the next bigger space is this 16-bit division. That's how you can decide, by looking at the number.
Okay, sir.
Fine?
Yes, sir.
All right.
So, and what's about the sir multiplication, sir? And is this
The multiplication, if you want to multiply 2 numbers, same as before, let's say I give you one number which can be stored into the 8-bit source, right? And it
Yes,
can be stored into another 8-bit source. Then you can do 8-bit, 8-bit. Let's say I ask you to multiply a 9-bit number and an 8-bit number. What you are going to do? Is it possible to store the 9-bit number into AL?
so it's
No, not possible because AL is 8-bit.
yes, sir.
So that means we need to convert the 9-bit number into 16-bit, that means this one, and 8-bit number into 16-bit because both of the numbers should be same size. Then we can do multiply this in the 16-bit multiplication. So based on the number, you choose which format you are going to use.
Okay, sir.
Fine. Anything else, anyone?
Sir, carry an overflow flag, sir, in unsigned multiplication and signed multiplication, sir, are they opposite, sir? Sir, I have
No.
confusion in this.
No. Look at, okay, fine. So look at this. So let's say, for example, we do multiplication. Let's say this one. We are going to multiply -1 to +6.